Hey guys, this is Coach Lowe, and this is Contextual Geometry 6-2. We're going to talk about altitudes and perpendicular bisectors. So first, let's talk about a few definitions here. Definition of altitude is a perpendicular segment with one end point at a vertex and the other end point on the side that's opposite of that vertex. So altitude here, it's going to be perpendicular to the base or the opposite side of that vertex. So in this case, if I'm starting out at point A and going over to side CB, which would be opposite vertex A, this would be my altitude, and it is a perpendicular segment. So we would have the right angle symbol on that segment piece. Now, we can also draw a perpendicular segment from C. So there is the perpendicular segment starting at the vertex C and ending up on side AB. And then we can draw one from B. So every triangle has three perpendicular segments or altitudes. And each one of those has a length that we definitely could use for that triangle. We also know that where those three altitudes meet has a special name. So this point P, where those three altitudes meet, is called the orthocenter. And we will talk more about that soon. All right, so this is an acute triangle, by the way. So this is case number one, an acute triangle. So let's look at a right triangle. Well, a right triangle, when I look at the altitude of a right triangle, the altitude here could just be the side of that triangle. So if I look at triangle ABC here, I can see that, yep, that is a right angle and it is perpendicular. And if I come this direction from C to B, same. So as I come from this vertex here or from A, it's just going to be the side of the triangle. Now, if I go from B, it's not the side of the triangle, is it? So as I draw this line segment over here, there is my altitude. And so where these three bisectors meet, see if I can get a straight line drawn here, where these three bisectors meet, one, two, yeah, I shouldn't say bisectors, where these three altitudes meet here at point B, notice the orthocenter is actually on the right triangle. Orthocenter in an acute triangle is inside. Orthocenter on a right triangle is actually on the triangle. So let's look at this one, finding the altitude of this obtuse triangle. So let's call this one ABC also. And as I draw the altitudes here, there is a perpendicular segment from C. And as I draw the altitude here, I'm noticing, I'm going to have to come outside, aren't I? Because the perpendicular would be here. All right, so let me go ahead and make a little dashed line there. And then as I draw from B, I see there's no right angle here. So it will also have to come outside, won't it? And so as I draw these, extend these lines on out here, I see that they will intersect. See if I can get this one moved just a tad. Come on, little guy. I see that as I get those drawn here, they will intersect, but they intersect outside. So my orthocenter for an obtuse triangle is outside the triangle, outside the triangle. So there are altitudes for each of those types of triangles. Now you do not have to draw 3, but you can see that there can be 3 altitudes drawn. All right, so let's talk about perpendicular bisector, a perpendicular segment that bisects the side of a triangle. All right, so an altitude was a perpendicular segment. It starts at the vertex and it is perpendicular to the opposite side. That was the first thing we looked at. Now we're looking at a perpendicular bisector, which is going to bisect the side. It does not have to come from the vertex, but we've drawn, and we'll do this in class too, we've constructed segment bisectors. And so what I would like to do now is cut this segment in half. And so if you remember, we put our point of our compass here and the pencil out here and swung it above and below, and we did the same here, kept keeping the same distance above and below, or the same setting, and it gave us a bisector perpendicular here. So that would be a perpendicular bisector. Now remember what that means. Bisect means cuts into 2 equal parts here. So if I have segment AC, and let's say this is point M, I now know that segment AM is equal to segment MC. They are the same measure now because this is a perpendicular bisector. It's a bisector. So bisector means cuts it in 2 pieces. Perpendicular means it's going to form some right angles where it meets at that side. And again, we can draw 3 of those perpendicular bisectors. So there would be a perpendicular bisector to side AC. There would be a perpendicular bisector to side BC and a perpendicular bisector to side AB. And as I draw those in, where they intersect is called the circumcenter, and it will actually be in the inside of the triangle, which we will totally look at in class together, but you are welcome to try that out on your paper. So this is a perpendicular bisector, and I'm just going to go ahead and draw an altitude in here so that you can see the difference. An altitude would come from this vertex and go down to the base, the opposite side, in this case, side AC. So it would go to the opposite side and be perpendicular. So this is the altitude coming from the vertex to perpendicular to the opposite side, and this is the perpendicular bisector. That is perpendicular to side AC and cuts it in half. So hopefully that makes sense on the difference between the two. All right, now we're just going to pick out these differences in some pictures. So let's check this out. So number 1, is that a perpendicular bisector or is that an altitude? So coming from the vertex, going to the opposite side, forming a right angle, this is, yeah, it's an altitude. All right, so let's look at number 2. It is coming from the vertex, so it might be an altitude. Now this can be a neither. It might be an altitude coming from the vertex. It's not perpendicular to this side, and it doesn't show that these are congruent or equal in measure, so this is nothing, unfortunately. All right, number 3, coming from the vertex along the side of the right triangle. This is an altitude. It's not cutting that side in half or anything like that. All right, let's check out number 4. This is a bisector, but is it perpendicular? Is it perpendicular to that side? No, it is not. A perpendicular bisector would be somewhere right in there, and it would have a little mark. So this is nothing. It is not an altitude either because it's not perpendicular. All right, let's check out this one. So I have an altitude, which is also the perpendicular bisector. Notice the markings that these sides are equal. So I have an altitude and a perpendicular bisector on that one. All right, number 6. It is not coming from the vertex, so probably a perpendicular bisector. Is the line perpendicular, and is it dividing the side into 2 equal pieces? Yes. So perpendicular bisector. Remember, that's a symbol for perpendicular. Perpendicular bisector. All right, you try number 7, 8, and 9. All right, now that we're back, This should be both. It is an altitude because it's coming from the vertex and it is a right angle, but it also splits that side in half. So it's also a perpendicular bisector. All right, number 8. You should have said altitude. Coming from the vertex, heading to the opposite side, perpendicular to the opposite side. Number 9, you should have said perpendicular bisector. It's cutting that opposite side into 2 equal pieces. All right, try 10, 11, and 12. Pause the video. All right, now that we're back, this is a nothing. And this is a perpendicular bisector. And this is a both, coming from that angle, splitting that opposite side into 2 pieces. All right. Why is this not recording? Maybe it is recording. Yay, hopefully. We'll see. All right, so let's try 13, 14, and 14. Wow, that's awesome, huh? 13, 14, and 15. Name the segment in the triangle that is an altitude. And then we are also going to name the segment that is a perpendicular bisector. So a segment that is an altitude and a segment that's a perpendicular bisector. All right, so perpendicular bisector, I see that is segment FD. I do not see a segment that is an altitude. AC could possibly be an altitude if this is a right angle, or BC could possibly be an altitude. This is not an altitude. It is coming from A and heading to that opposite side, but it is not perpendicular. All right, so AG would be not an altitude and not a perpendicular bisector. If they would mark AC, then we could put AC here, or we could put BC, but I don't see that it's marked, so I don't see that that has a good answer there. So I'm going to go with nothing on that one. All right, guys. Well, good job, and I will see you guys soon. This is Coach Lowe, and I'm out.